All right, applications. This is the beginning of where we are looking at application problems. For the ready here and the set. The set is where you're going to need to actually apply this here. But the ready, we're just kind of doing some groundbreaking stuff, and we're talking about how do we set these up. And this diagram here is to help you, or diagrams are to help you kind of set these up, because you've probably heard a picture is worth 1,000 words. Well, maybe not 1,000, but a picture is worth actually something, especially when you're trying to solve and find things. Jill put a ladder up against a house and is trying to reach a light that is out. It needs to be changed. She knows the ladder is 10 feet long, so I'm going to highlight that. There's some dimension. And the distance from the base of the house to the bottom of the ladder is 4 feet. Think about a ladder leaning against a house. If this is my ladder, ladders don't go against houses this way. Ladders don't go against houses this way. Ladders go against houses this way, right? They go at an angle. So when we look at this diagram, I'm going to look at it a couple of different ways. I'm going to look at it as a triangle, and I'm also going to look at it as a rectangle. Now, why both figures? Well, you'll see eventually as we go through and do this why both are important, right? If I look at this diagram as a whole, both figures, and it says a ladder is 10 feet long, what part of the diagram represents the ladder? The part of the diagram that represents the ladder, you might say, oh, it's that line. Well, that line doesn't tell me what that line is. I want to be specific, and I'm going to be petty, but yes, be specific. The ladder is the hypotenuse of the triangle, or the ladder is the diagonal in the rectangle. Either or should tell the person you are trying to draw this for, or tell you, or if somebody picks up your paper and you're trying to explain to them, it's the diagonal in the rectangle or the hypotenuse in the triangle, they should understand that that represents the ladder, and the ladder is 10 feet long. Now it says the distance from the base of the house to the bottom of the ladder. Well, I would take this even one step further, and I would go ahead and maybe even draw my house. Here's my house, right? I'll even draw it with the front door and a window, right? And I might even draw the little light right here. Okay, that's the light that needs to be changed, right? The ladder's leaning against the house. Now, the diagram's not to scale. You wouldn't lean a ladder this way. If this was an actual house, your ladder probably would be more like this. Yes, we know that. But again, the diagram is more of a reference thing. What do they really want to know in this picture? They want to know, how high is the light? How high up is the light? So what part of the figure is that? The part of the figure that is the light is the distance of the house, or how far the light is above the ground, or the distance is the left side of the rectangle, or it's the left side of the triangle. That's or short leg of the triangle, even for that matter. Right? So start thinking that terminology. No solving, just setting up. We do the same thing in number 2. Francis is flying an airplane at an altitude of 3,000 feet. When he begins his descent, all right, so what does the word descent mean? Toward the ground. The plane has an angle of 15 degrees, that's another notable, and a descent. There's that word again. What does that word mean? Descent means going down. You were given, after your quiz, and if you didn't get one, ask, but you were given a green sheet of paper. And on this green sheet of paper, talks about angles of elevation and angles of depression. It talks about horizontal lines, lines of sight, and so on. All right? Everybody pretty much knows what elevation is at this point. Elevation is going up. So think of it that way. Elevation up. Depression, not sad face depression. In math depression means going down. There's a depression in the earth, or geology, or whatever. Depression that way means going down. All right? Descent means going down. Ascent means to go up. So descent means going down. All right, so yes, I am going to do this here. Here's my airplane. All right, there's the, yeah, go ahead and laugh. It's okay. My stick figures are horrible. But again, the diagram is reference. I'm not going to grade you on artistic ability. All right, so the plane is at an altitude of 3,000 feet. What represents 3,000 feet? We're just drawing and labeling. That's all we're doing. Okay, you should say the left side of the rectangle or the short leg of the triangle. That is my 3,000 feet. All right. what begins the descent towards the ground? The plane has an angle of descent of 15 degrees. And a lot of people default, and this is what I have, they default, this is 15 degrees. They are close, but they are wrong. This is not 15 degrees. Go back and look at this paper. The angle of descent. It talks about right here. Angle of depression, angle of descent is the same way. If I draw a rectangle, is that angle of depression inside the triangle or outside the triangle? The angle of depression is actually this angle right here. Now why? Why is it that way? Well, let's look at this from a rectangular standpoint for a second. Ignore that the triangle is there. If I look at it from a rectangular standpoint, here's the top and bottom of my rectangle. They extend infinitely in each direction. All right? Here is the diagonal of my rectangle, or the hypotenuse of my triangle. What we end up having here is and we got to go all the way back to module 5, what we end up having is alternate interior angles. Alternate interior angles are congruent. So the angle outside, the upper left angle, not including the triangle, is 15 degrees. The lower right angle in the triangle is 15 degrees. And this is important because when we do trig, if we need to do trig to find these, I have to know one of the acute angles inside the triangle. I have to, right? Alternate interior angles allows me to be able to do that. And again, it just says set it up, it doesn't say solve. But if I wanted to solve for how far the plane is from the airport, this is where we have to pay attention. How far is the plane from the airport? That's the base of the rectangle or the base of the triangle. If I want to know how far the plane's going to fly, that's hypotenuse. So we'll talk more about that. And then lastly, Abby's standing at the top of a very tall skyscraper. Immediately I go to this. I go to, here's my tall skyscraper. Right? We don't see skyscrapers around here. Okay? If you go to LA, maybe you see them. If you go to Chicago, New York especially, you see them. Looking through the telescope at the scenery all around her. The angle of decline. Here we go. Decline. The other was descent. Now we get decline. What does decline mean? Okay? The telescope says 35 degrees, and Abby knows she is 30 floors up, and each floor is 15 feet tall. So label your diagram with its dimensions. Well, again, Abby's up at the top. Okay? She's on the tall skyscraper. She's looking down. All right? Angle of descent is 35 degrees. What does descent mean? Descent means down. Depression, descent, depression, decline, they all mean downwards. So here's my 35 degree angle, which if that angle is 35 degrees, do we know one of the angles inside the triangle? Yes, it's this one over here, alternate interior angles. Okay, again, that helps us. And she knows she's 30 floors up. Now some people are going to go, well, 30 floors and 15, what does that mean? 30 floors, 15 feet, what does that mean? Well, this allows me to find the overall height of the building. Remember, if you go up one floor, you're 15. You go up two floors, you're 30. You go up 3 floors, you're 45, and so on and so on. Who wants to count 15 plus 15 plus 15 plus 15 plus 15 when you can multiply 30 times 15 and you can get 450? All right, so that's how tall the building is. Now, they're not asking us to find anything. If they wanted to ask us to find out what is that thing she's looking at on the ground, or say she sees somebody she knows, hey, Bob, how far is Bob from where she's at? That's going to be a hypotenuse. How far is Bob from the building? That's going to be a leg. Right? So your plan was to, or is to, go ahead and label these diagrams. Now, for here, you need to find out which trig function to use, because in here, in number 3, we use trig. In number 2, we'd use trig. In number 1, I would use Pythag. You could use trig, but I'd use Pythag. So anyway, that was your goal with 4, 5, 6, and 7. So work on that. Bring your questions to class.